Hey everyone, Simon's here. I'm going to go over the notes on verifying trigonometric identities. You'll notice we have some guidelines up here. It says there's no well-defined rules to follow in verifying trigonometric identities. It is best learned by practice. To be honest, this is not easy. I understand that these identity things are not easy. I understand that it's not how your brain works, that you always know what your answer is or what you're looking for in an answer, and some of these are hard. Verifying them is a little easier than the last two times that we had notes because we have an end goal in mind. So here's a guideline. It says work on one side of the equation. It is often better to work on the more complicated side first. You can only work on one side, so pick the more complicated one. Look for opportunities to factor an expression, to add fractions, to square a binomial, or to create a monomial denominator. Number 3 says look for opportunities to use the fundamental identities that we've learned. 4 says when the preceding guidelines do not help, try converting all terms to sines and cosines. Sometimes that is going to fix everything, right? And number 5 says always try something. Staring at it's not going to make it work. All right? So in this first dude, I'm going to try to change this side to look like this side. Again, we want to start with the more complicated side. So we have an identity that says 1 plus tangent squared x is equal to secant squared x, right? So secant squared x minus 1 can be replaced with tangent squared x. So we're going to do tangent squared theta over secant squared theta is equal to sine squared theta. Now, here's one of those times that I know I'm looking for sine squared theta, so it might be a good idea at this point to change everything to sines and cosines. So tangent is going to be sine squared theta over cosine squared theta. And that's all over secant squared theta, which I could rewrite as 1 over cosine squared theta. This is equal to the other side, sine squared theta. You must keep writing this side every single time, and you can't do anything to the side. You can't multiply anything by it, add or subtract anything to it. It needs to stay exactly as it was on the first, when we first did the equation. So here I'm going to multiply by the reciprocal top and bottom, because that's going to make that denominator away. Those are going to go away, and I'm literally left with sine squared theta equals sine squared theta, and we are done. We have shown that that is, in fact, equal to sine squared theta. All right, you're supposed to try the you try, so pause the video. So I look at this and say, everything over here is cosines, but I have a cosine and a sine over here. So let's see if we can find a way to change this sine squared beta. So cosine squared beta minus. Remember we have that Pythagorean identity that says sine squared theta plus cosine squared theta equals 1. I need sine squared theta by itself, so I could subtract cosine squared theta from both sides, right? So I could rewrite this as 1 minus cosine squared beta, and that's supposed to equal 2 cosine squared beta minus 1. I'm going to distribute this negative through. This is going to give me cosine squared beta minus 1 plus cosine squared beta, and that's still equal to the other side. Now I have 2 cosine squared betas, so 2 cosine squared beta minus 1 is equal to 2 cosine squared beta minus 1. So here we're done. We have proved that one side does in fact equal the other. This one says combining fractions before using identities. So we probably want to combine these. I just have this 2 secant squared alpha on this side. So what I am going to do, I'm this plus sine theta. I'm going to multiply this one by 1 minus sine theta. So I have 2 secant squared alpha is equal to, I'm going to multiply this by 1 plus sine alpha over 1 plus sine alpha times the first fraction. And then I'm going to multiply this by 1 minus sine alpha over 1 minus sine alpha times the second fraction. So the left side, again, not going to change. We have 2 secant squared alpha is equal to. So now my denominator is 1 minus sine squared alpha. When we multiply those out, that's what that becomes. Now in the numerator I have 1 plus sine alpha, and that's being added to 1 minus sine alpha. Sine alpha and negative sine alpha are gone, so I have 2 secant squared alpha is equal to 2 over this 1 minus sine squared alpha can be rewritten as cosine squared alpha. Again, that's in the denominator, so I can rewrite identity, which happens to be secant. So now I am done. Secant squared alpha, and that shows that one side is, in fact, equal to the other. All right, I'm going to go to the back. So sometimes you want it as a single fraction, and sometimes you don't, and this is one of those times. So we are going to write this as tangent x over this common denominator, tangent x, cotangent y. Plus, now I have cotangent y over tangent x, cotangent y, and that's equal to the other side. Now these divide out. When this divides out, you're still left with a factor of 1 in the numerator. Same thing here. Those divide out, you're left with a factor of 1. So this becomes 1 over cotangent y plus 1 over, I'm writing that wrong, hold on, tangent x, and that's equal to tangent y plus cotangent x. Well, these are reciprocal identities. So 1 over cotangent can become tangent. This is tangent y then. 1 over tangent becomes cotangent. So I have tangent y plus cotangent x, and now it does, in fact, equal the other side. All right, we are going to use the trig identities to fix both of these. So tangent squared x plus 1 can be replaced with secant squared x times. Now, we did this one in note 16, and I'm just going to do it again on this side just so you can see it. So cosine squared x plus cosine squared x equals 1. I need to make this look like cosine squared x minus 1. So I need to subtract 1 from both sides. That also means I need to get the sign moved to the other side, so I'm subtracting it. So this is gone on that side, that's gone on this side. This gives me cosine squared x minus 1 is equal to negative sine squared x. So this becomes sine squared x. Negative, sorry, I forgot the negative. Is equal to negative tangent squared x. Well, secant is the reciprocal of cosine, so this becomes 1 over cosine squared x times negative sine squared x over 1. So now I have negative sine squared x over cosine squared x, which happens to be tangent. So, and it's negative divided by a positive, so negative tangent squared x equals negative tangent squared x. And we are done with that one. The next one looks really ugly. It's not near as ugly as it looks. Okay, so I'm going to go ahead and distribute this through. So I have cosecant squared x minus cosecant x sine x plus, I'm going to write this as 2 separate fractions, sine x over sine x minus cosine x over sine x plus cotangent x is equal to cosecant squared x. it's always a good idea to look at what you're aiming for. We need to get it to equal cosine squared x. I have one of those right there, so that looks like everything else here has to go away, right? So cosecant squared x minus cosecant is the reciprocal of sine, so this becomes sine x over sine x. And sine x over sine x is 1, minus cosine over sine is cotangent. Now this becomes 1. Cosecant squared x minus 1 plus 1 minus cotangent x plus cotangent x, and that equals cosecant squared x. Well, the plus and minus of cotangent x are gone, plus and minus 1 are gone, and that leaves me cosecant squared x equals cosecant squared x, and we're done. All right, this one we need to convert to sines and cosines. It says that there, but it may not. You may not be clicking as to why. So let's go ahead and get started. Tangent is sine x over cosine x plus cotangent is cosine x over sine x, and that's supposed to equal secant x cosecant x. Well, in order to add these, I have to have a common denominator. So I'm going to multiply this fraction by sine x over sine x, and I'm going to multiply this fraction by cosine. Sine squared x over sine x cosine x, plus I have cosine squared x over sine x cosine x, and that's supposed to be equal to secant x cosecant x. Now these have a common denominator, so I'm going to rewrite this as sine squared x plus cosine squared x over sine x cosine x, and that's equal to secant x cosecant x. Well, sine squared x, cosine squared x becomes 1, so I'm left with 1 over sine x cosine x. Now 1 over sine x is cosecant x. 1 over cosine x is secant x, and that equals secant x cosecant x. We can multiply in any order, so those are exactly the same. Lastly, I'm going to work on this problem. You should write this as two separate fractions, so 1 over secant x plus cosecant x over secant x minus cotangent x is supposed to equal cosine x. Well, 1 over secant x could be rewritten as cosine x, plus cosecant could be rewritten as 1 over sine x, so I'm going to do the 1 over sine. Secant is the reciprocal of cosine, so we end up with cosine x So now I have cosine x plus cosine over sine is cotangent x minus cotangent x is equal to cosine x. And negative and a positive cotangent go away. I'm left with cosine x equals cosine x, and we are done. Have a great one. Until next time.